Welcome, virtual students. You are in 5th period class with us. Here's what I need everyone to do, everyone in class here, and also those of you that are virtually. Turn to page 744 in the book. 744. We are moving on into Module 14. Module 14. As I introduce this for virtual and for students in here, was there anybody on Friday that has not taken the quiz? Anybody in here? Okay. Virtual students, if you have not taken the quiz, you need to reach out to me. All right. So we are in Module 14, and on page 744, you're going to see a box that says the law of signs. Go ahead and copy that into your notes. Give you a few moments here. Law of signs, copied into your notes. We follow the same pattern when we're creating these triangles. Capitalization is used for each vertex, each vertice. Lowercase letters are used to represent the length of sides. So you can see how it's labeled correctly. And then the law of signs, as you copy it into your notes. By the way, side note, why do you think I like for you to copy this stuff into your notes? I mean, it's already written in your book. Why do you think I like for you to write it into your notes? Anybody know? There is scientific research that shows that it helps your memory to actually write it down. So you take the action of writing is one way to activate the memory. And so that means it helps your comprehension. Okay? Another thing to do would be to try and remember what you write by closing your eyes and thinking about what you just wrote. That's a way to work on your memorization skills. Close your eyes and think about what you just wrote. But that being said, let's go ahead and go through. All the law of signs is a proportion. We take the sine of the angle and we write it as a ratio over the opposite side. So it's lowercase a. And then it's a proportion. So equals the sine of the next angle. Doesn't matter which one we use. We'll go B first. Over the opposite side. And then the last one, still a ratio and a proportion, sine of C over lowercase c. So all of that is the law of signs. A couple things that I have to tell you. Number one, all of Module 13 was dealing with right triangles. This is not. There are no right triangles. Or I should say it like this. The sine law applies for any type of triangle. Okay? Today, we're only going to look at acute triangles. Tomorrow, we're going to look at obtuse. But it applies for any triangle. Okay? The sine law works for any triangle. All right, so now, before we do a sample from this type, let me shake your memory. What if we had a proportion that looked like this? there's a proportion, Lydia, that says 4 is to 9 as x is to 27. Going back to middle school math, Lydia, how do I solve that? Out 9 times x. Outstanding. 4 times 27, 9 times x. So that's 28. What is that? 108 equals 9x. Carly, what do we do next? Very good. Divide by 9, and we end up with what? What is that? 12?
Oh, I just filled in the blanks.
That's fine if you remember, and it's an even, that you multiply by 3, and you multiply by 3.
Yeah, that's what I did.
But I want you to know how to solve the proportion this way, because we're going to use it for the sine law and solving the sine law. Is everyone good with that? Okay, good. So turn now in your book to page 746. Page 746. Let's move this all the way up to the top of the screen. At the top, you're going to see number 4. Let's work on this one together. Let me catch up to you and write down what they have. Okay, so we have a triangle. Put in the details. This is C, and it's 42. This is A. This is the number 8. This is B, and I believe it's 28. So lowercase a and lowercase c. So we've really got 3 unknowns. They've given us 3 parts of it, and a lot of the law of sines, the whole purpose is to solve triangles. All right, what's that mean to solve triangles? We find all 6 parts. We find all 3 angles and all 3 sides. Okay, and so we've got 3 unknowns we've got to use. We're going to set up an equation. By the way, before I keep going here, can I use the Pythagorean theorem? No, why not? It's not a right triangle. That's a common mistake. Don't make that mistake. Can't use the Pythagorean theorem. Okay? All right, so let's set up the proportion. Let me find a good one here. I'm going to go the sine of 28 is to 8. That's the side opposite. And then I don't know what the measure of angle A is. Not yet. I'll figure it out. But I'm going to go ahead and use the sine of 42. And that's opposite side C. Now, just with my practice of solving proportions, I've got 3 sides. Now, see, Joanna, why I can't use the method that you used before? I have no way to fill in the blanks here. I don't know that. I don't know if the sine of 42 is 2 times 28, and so that would make C equal to 16. I don't know. So I actually have to cross multiply and divide. Okay? So here we go. We're going to take C times the sine of 28, and that's equal to 8 times the sine of 42. Everyone okay there? That's just the cross multiplication. Aaliyah, we good? Colton, got it? Now, our unknown, if I were teaching you in Algebra 1, I would say a good habit to be in is to make sure you know where your variable is. So I put a little square around it. Ava, does that make sense? Now, I'm going to isolate the variable by undoing whatever they're doing to our variable. Well, they're multiplying it by the sine of 28. How do I undo multiplication? By division. That's right. Divide. So whatever I do to one side of the equation, I have to do to the other side. Notice I haven't substituted any decimals in. There's no need. Not yet. And so the signs of 28 cancel. And so I'm left with the equation. I'll move it up to the top of the screen for you. C is equal to 8 times the sine of 42 over the sine of 28. Now let's use our calculator. You might be using your phone, but let's find the value of C. Here we go. Very clear. So I'm going to go 8 times the sine of 42. It gives me a decimal. And then I'm going to divide that by, I could write it down, but I don't need to. I can just hit the divide button, and it takes the answer, and I'm going to divide it by the sine of 28. And that's going to equal 11.4. So C, I'm going to use the approximate symbol as 11.4. Okay, so that does that. Now, let's go back to our picture. I'm going to put that 11.4 in right there. All right, without using a calculator, Aurora, what's 28 plus 42? No.
70. Oh.
70.
Yeah, 70.
All right, if all three angles add up to be 180, Aurora, and that one, those two add up to be 70, what's the measure of angle A? 110. Say it with confidence, Aurora. 110. That is correct. Okay, we're almost done. Now we've solved for C. We've solved for the measure of angle A. Now we got to solve for side A right here. Okay. All right, so let's do that. We're going to use the sine law again. We can't use Pythagorean theorem. We're going to solve for A. We're going to go the sine of 110. I like this gray pen. I like it. The sine of 110 over the opposite side of A. And we'll go the sine of 28 over 8. Could I have used the sine of 42 and 11.4? Yeah. But 11.4 is an approximation, right? And so I went ahead and used one that wasn't. Okay, cross multiply and divide. 8 times the sine of 110 is equal to A times the sine of 28. Where's my unknown? I'm going to put a little box around it. A is my unknown. Now I'm going to divide by the sine of 28. Because I have to isolate my variable. Okay, so now I have A is equal to 8 times the sine of 110 over the sine of 28. Let's get the calculator humming. Clear, clear, clear. 8 times the sine of 110 equals divided by the sine of 28. 16.0, and that's equal to, approximately equal to A. Questions? Okay, good. Now, let's check for your understanding. How well did you get this? Look at the next problem on the same page. Look at number 5. Go ahead and try that on your own. Number 5 on the same page. I'll give you 2 or 3 minutes. there's only one thing you can do at the start. You go sine of 33 is to 12 as the sine of C is to 15. A quick reminder, if you're finding the measure of an angle, you must use the inverse button. Don't forget. Don't forget, Aaliyah. You forgot. Let's cross multiply and divide. Okay, those of you that are stuck, take a look at the screen. Virtual students, pay attention. All right, so to find the measure of angle C, we have to use the inverse. But first of all, we got to find the decimal. So we're going to take 15 times the sine of 33, and then we're going to divide that by 12, and that gives me the decimal. Now look at this. There's a little trick here. Let's see if I can show it on the screen. Virtual students, you just have to listen. You guys see that A and S? Kind of hard to see. Can you see it or not? Let me focus it. All right, so on a calculator keypad, you see that says A and S? It's a little function that all calculators have, okay? All calculators have that allows you to kind of skip a step. Let me show you. So here's the decimal. And so if I want to take the inverse of that, let me write that out. I'm going to go inverse sine. But I'm going to write this just so you understand what I'm doing. A and S. I want the inverse sine of this decimal. Does that make sense? So here we go. Second sine. Now, it's almost like the calculator already memorized or put it in memory what was the answer. I'm going to go second answer. And see how it plugs it in? It's like it was in memory. It was stored. Now I hit enter. Aha. It's a little nice little function that calculators have. Now, if you didn't know it, you wouldn't know. So C then is approximately equal to 42.9 degrees. Okay? So 42.9. Now, if you don't remember how I did that, if you're a virtual student, you can go back and watch the video. Just rewind. Those of you that are in here in class, just go to the video on Canvas. It'll be loaded later. And you can go over it again. Listen carefully. Okay, so now we know that that's 42.9. Let's do our math in our head again. Who did I pick on last time? Lydia? Ava. You're the winner. Ava, what's 33 plus 42? You're not supposed to use your calculator. Yes, you can.
It's like
75.9. All right, now Ava, if I'm subtracting that from 180, well, if it's just 75, that'd be easy. It's 105, right? But it's 75.9, so that's going to be 104.1. Very good. There's A. Okay, now we're going to use that to help us solve for the side of A. So we're going to go sine of 104.1 over lowercase a. I think I'm still on the screen for you guys. And then we'll go the sine of 33 over 12. Does it matter if I use sine of 33 over 12? Or could I have also used the sine of 42.9 over 15? Yeah. Now, it's not quite as accurate because 42.9 is an approximation, but it would work. All right, so let's cross multiply here and then divide. And so we end up with that A is equal to the sine of 104.1 times 12 all over the sine of 33. Cross multiply and divide. Okay, now let's use the calculator and simplify. Clear, clear, clear. Sine of 104.1 times 12 divided by the sine of 33. 21. What is that, 21.4? Yeah. So A is approximately equal to 21. Questions? Are we good? All right, we've got one more problem to do with the virtual, and then here in class we're going to do another problem. All right, so turn to page 750, and I want you to look at number 9 at the top of the page. This eventually will be one of the homework problems, but look at number 9 at the top of the page. Go ahead and take 2 or 3 minutes and see if you can figure this one out. Number 9, top of the page. All right, there's actually a shortcut on this one. Maybe somebody out there saw this, maybe not. But if this is 80 and this is 50, that gives you 130, right? If that's 130, then that makes this 50. Ah, did anybody recognize that this is an isosceles triangle? If it's an isosceles triangle, if the base angles are equal, then the opposite sides are equal. That means that side A is 10. That makes it a little bit easier. Okay? And so then to solve, I'm going to use the sine law. The sine of 80 is to b as the sine of 50 is to 10. Now I cross multiply and divide. I'm solving for b. So I have 10 times the sine of 80 over the sine of 50, and that's equal to b. Cross multiply and divide. And so then I have b is equal to, let's see, let's put it in the calculator and work it out. 10 times the sine of 80 divided by the sine of 50. 12.9.
I did a different proportion, but I still got the same answer.
What'd you do?
I did sine of 80 over sine of 50.
That'll work.
And then b over 10.
Yeah, no, that would work. And then b over 10. That would work.
Will that matter if I do that on
Nope.
any of them?
Nope, that would work. Okay, so I'm going to sign off on the virtual. The rest of you in class, go ahead and do number 10. Okay? And then I'll catch up with you. I want to sign off on virtual and get it posted. If you have any questions, virtual students, send me an email. Glad to have you back.